What is up, party people? We are on our 13th Swift Playgrounds stream, and I hope in the description I spelled 13th right. I didn't proofread, but the more I think about it, the more I think I might have spelled it wrong. Anyways, that's besides the point. You know what I mean. 13th. I should just do that instead of spelling it out. Anyways, we're almost done with Swift Playgrounds, which will be like we'll be finishing up our second I don't even know what you want to call it, course. We finished up all of the Star Wars The Force coding kit. If you haven't seen those, check them out. They're pretty sweet. And this is our second one, Swift Playgrounds, basically Introduction to Coding. So we're on our last chapter here, algorithms. So let's get into the introduction. I guess before we do that, we finished our while loops chapter last stream, and this is the code we did. So basically, we just ran a for loop and just did a bunch of while. It did a while loop inside of the function, and then did an if else, and we're able to solve this puzzle. So if you're curious or need a refresher, go and check that out. But let's get into algorithms. So algorithms, one step at a time. An algorithm is a set of rules and instructions you use to solve a problem. For example, a navigation app uses an algorithm to figure out the fastest path to where you want to go. Cool. To avoid traffic. Compare distances and average speeds. Compare current traffic conditions. Select route with shortest travel. Makes sense. Now suppose you need to direct a car around a building to find a parking space. What instructions and rules can you use to move the car around the building? You say while is not in parking space, drive forward. Oh boy, the car just drove off the screen. To start, write an algorithm that moves the car forward until it reaches the parking space. So this one does, to move the car around the building, create a rule to repeatedly check whether it is blocked on the right. So if it's blocked on the right, drive forward, else turn right. If the car is not blocked on the right, it has reached the end of the building and should turn right. Oops, we still need to tweak the algorithm. So then once you're able to turn right, drive forward. After turning right, the car should drive forward to go around the building. A lot of the code you've written so far has been instructions to solve problems. In this sense, you've been writing algorithms the whole time. The skill you're adding now is the process of writing and tweaking code so you can use it in different situations. So like that last slide said, we've technically been writing algorithms this whole course, but now we're introducing this process of algorithms to basically be able to say, hey, I can, and we've talked about this in previous videos, but basically being able to reuse the code you write. So all the functions that we write, making them reusable enough to where like this will work in any circumstance no matter what. So pretty much algorithms are being able to reuse the functions that we're writing. So that's kind of cool. So anyways, let's get started on this first one. Let's see what we got here. The right hand rule. So the goal is to use the right hand rule algorithm to navigate around walls. Okay, so we got, kind of hard to see, but we got some walls here, and we got byte right here, and we got a bunch of waterfalls and stuff. Run this puzzle and notice how your character stops after the first gem. The algorithm used here follows the right hand rule to move around walls to solve the puzzle. You'll need to tweak the algorithm, but first try using pseudocode to plan the action. So what is pseudocode? Pseudocode looks like a bit like Swift code, but is worded and structured so humans can easily understand it. So pseudocode is basically explaining what's going to happen in words. So navigate around the wall. If blocked to the right, move forward, else turn right and move forward. And then basically while you're not on a closed switch, navigate around the wall. And if you're on a gem, collect the gem and turn around. And then, but if you are on a closed switch, toggle the switch. So based on the pseudocode above, write out a solution in code for the puzzle. Run your code and tweak your algorithm if necessary to solve the puzzle. Okay. Should we just run this to start and see what happens? Let's run this. So we're gonna navigate around the wall. So I'm blocked, so Byte's blocked to the right. So he's just gonna keep on moving forward. Still blocked. And now he's not, so it looks like he's gonna turn right, move forward. Now he is blocked to the right. So we're just gonna move forward again. Now he's not, he's gonna turn right. Move forward. Boom. And boom. And now he's... So now, that's around the first wall. So how do we get around all the other walls? So based on the pseudocode that we went over, so we have navigate around the wall, which is right here. This is the first function. And then we say, while not on a closed switch, navigate around the wall. If on a gem, collect the gem and turn around. So this is the while loop that we will have to edit. So instead of is not on gem, let's do while not on a closed switch. Okay. And then we'll navigate around the wall just like we had up here, up at the top in the pseudocode. And then we'll say if is on gem, similar to like what they were describing in the pseudocode, we're going to collect the gem and then we're going to turn around. So how do we turn around? We can go left twice, right? So we'll go we could make a function, but we're just going to turn left twice. So this algorithm's changed now. So while we're not on a closed switch, this is going to keep on running. We're going to run navigate around the wall, and we're going to move forward or if we're blocked on the right, and if we're not blocked on the right, we're going to turn right and then move forward. And then but if we're on a gem, we're going to collect that gem and then turn around and then keep on going. So let's step through this a little faster. Let's just do run faster and see what happens. Let's see if this works. So he's going to turn, go around the wall, collect that gem, and then turn around and then just keep on going. And he's going to keep on running through this until he's on the switch. But I think we missed a step because we're going to be on the closed switch. He's not going to toggle it. Oh, we were so close. Okay, so if is on gem, collect gem. We need to now write a step for what happens when he is on a toggle or a switch. Sorry, get my words mixed up. So this while loop runs while he is not on a closed switch. So if is on gem, collect the gem. Should we do else? We could do else if should we do is on closed switch? Oops, and then we could do toggle the switch. We could try that. Toggle switch. So now we just added an else if at the end of this, basically saying if you're on a gem, collect the gem and turn around. And if you're on a closed switch, toggle the switch. So let's see what happens here. I have a good feeling about this one. A good feeling. Let's see if my soundboard works. Nope, it's not working. He's doing well though. He's doing well. He's got one more big wall to get around. Hey, oh! Did we just have an infinite loop? Look at, he's still just going forward the whole time. Whoopsies. So, why is this happening? Let's see. Oh, here, there's all my sound effects. So, else if he's on a closed switch, toggle switch. He's blocked right, and he's constantly moving forward. So what we could do, this is kind of a little hacky. What we could do if he's on a if you toggle the switch, then we could turn left. Or wait, hold on. Else if toggle switch. And then it should exit out of the while loop, right? Is on closed switch. Let's try this. Turn left. So he's gonna turn that way. Let's see what happens. We're gonna run through this fastest, see what happens. I'm just curious what happens if he just turns left. Because then he won't be blocked on the right. So he'll turn right and move forward. But then he won't be on a closed switch either. Oh, he's still moving forward. Stop. What's the hint say? Huh, interesting. Okay. Let's see. So can we step through this? I want to see what's happening. This is going to take a little bit longer. So he's blocked right, moves forward. Now he's going to turn right. He's going to go all the way down to this toggle. And then what's going to happen is he's going to essentially toggle the switch and then continuously try to move forward, which is not what we want. But he shouldn't do that because he's not while not is on closed switch. While is not on a closed switch. Maybe we should add another while loop, basically saying while on an open switch, but he wouldn't be on a closed switch. That's the problem, huh? I see. So I think we need to take this else if out and make another while loop, basically saying if you are on a closed switch, toggle the switch. Because right now, not on a closed switch is running every single time. Okay, I think I figured it out. Here we go. So we're gonna take this off. We're gonna delete this. Delete. Okay. So we have this if statement. And then we're going to do a second while loop, basically saying while is on while you're on a closed switch. So byte, if you're on a closed switch, toggle that thing. And that's it. Let's run through this thing fast. See what happens. I have a good feeling about this part. Can we get a cheer? Why doesn't my board work? It sucks. Whatever. I'm doing all of the sound effects, so it's gonna just explode. Alright, collected all the gems. There we go. Woo! And look at everything. Oh, I didn't die. Why did it say I died? Everything exploded at the same time too. All of my meme board actions. Okay. So I had to take the while loop out of the is not on closed switch. So that makes sense. So now this is reusable. So if you're not on a closed switch, you could use this anytime you need to go around anything that is on the right side. So like if, you know, this was just a big square or rectangle, you could still use the same thing and it would work. Pretty cool. So let's see what it says. Incredible. By writing a set of instructions and rules to follow, you've created an algorithm. Your algorithm can solve this puzzle no matter what size any of the walls are, making it reusable and adaptable, like we said, to different situations. Next, you'll see if a familiar algorithm works in a slightly different puzzle, or if you'll have to tweak it a bit. All right, let's see if it works. Whoa, this looks interesting. We got pictures in the description. That one took me a long time. This might be the last thing that I get through. But I guess that's... we went through 3 sections. Anyways, let's see what happens here. Okay, adjust your algorithm to navigate around extra blocks. This puzzle is similar to the previous one, but additional blocks around the walls prevent your right-hand rule algorithm from working properly. Okay, in some situations, you're blocked on the right, but you can't move forward because you're always blocked in front. Okay, so in some situations you're blocked on the right, but you can't move forward because you're blocked in the front. Adjust your algorithm to deal with these situations. Can I zoom in on these photos? Nope, it's just there. Blocked on the right and in front. Blocked on the right, so I can't go forward. And not blocked. To fix this, you'll need to tweak your algorithm. The image above shows the 3 different situations your character will encounter, and the arrows suggest how to respond for each one. You can modify, navigate around wall to handle each situation. Use pseudocode to think through how your character should move in the 3 situations. Okay, so we'll talk through it, and then based on your pseudocode, tweak the existing code below, then run it, see what happens. Okay, that's a lot. But anyways, so let's talk through this. So he's going to go around this wall, and he's going to be blocked on the right, and he's going to be able to move forward and turn. But once he gets to this gem, he's going to be blocked on the right and in the front. And basically what we're going to want to do is turn left, I think, right? And then do some stuff. And it's going to happen again right here. And it's going to happen a couple other times. So let's just, does it take exactly what I did? Nice. They made it a little more concise. They didn't do while because they're smarter than me. Let's see what this does. Let's just run fastest and see what happens. This is our existing code. So we're going to run. Okay, there we go. So we hit our first little hiccup here. So now he's just continuously running. Almost looks like he's just bumping his belly into the wall over and over and over again. He's going crazy. That's called an infinite loop. All right, so What should we do if he's blocked on the right and on the front? Turn left, right? Or turn left, correct? I shouldn't say right. Okay, so if blocked on the right, move forward. Else, turn right, move forward. So we should add, let's do enter here. And let's do else if, and then in this if we'll do, whoops, in this if we'll do, if you are blocked on the right and come on, and is blocked, just blocked on the front? I'm assuming so. Turn left. And then we'll get back into the navigate around while loop again. So let's try this. Let's see what this does. Run fastest again. Okay. It didn't do anything. Else if blocked right and is blocked. Why didn't it do anything? Stop. Step through this. Let's step through this. What's going on here? What is going on here? So you're gonna move forward. Did I like not format this right or something? Move forward. Move forward again. Maybe I should have combined this else. Turn right. It's like skipping the else if. Move forward. Okay. No, let's step through it. Move forward. Maybe I shouldn't do is blocked right and is blocked. Okay. Boom. We should add a space in here. So, if is blocked right. Let's just do else if is blocked. Turn left. See what happens here. It's running the is blocked right. So it's basically saying I am blocked right. It's not checking. Okay. Let's just do is blocked right. And whoa. And is blocked. And then we're gonna turn left. And this one is else if is blocked. Oh, whoops, I need to add parentheses right here. There we go. And then for this one, we're just moving the top one is blocked right, down one. And we're going to, what was that? Move forward. Move forward. Whoa, okay. Let's see what happens here. Guess and test, baby. Okay. Alright. Alright. Okay. So it's running through it now. I feel like we're gonna hit some sort of hiccup, won't we? So we're gonna get all the way to the switch. Is this gonna work? Is it gonna work? Hey, come on, baby. Oh, wrong thing. Nope, wrong thing again. There we go. Give me the applause. Let's go. That's great. So all we had to do there was basically say if you're blocked in front, turn left. And we moved the is blocked right down one. And that worked for everything. So that's pretty cool. We only had to add essentially 2 lines of code, and we basically were able to accomplish an even more complex problem that works. It's like almost backwards compatible, so it can work in either situation, the last exercise and this exercise. So that's pretty cool. Let's see what the text says. Super impressive. You've tweaked an algorithm to make it work in different circumstances. This is the power of code. Creating programs that solve a problem in many different situations. For example, search engine algorithms can filter over 1 billion websites to give you the results that you'll be most interested in, no matter what you search for. Pretty cool. Let's see, next page. Conquering a maze. All right. So my timer says complete up there, so I'm going to call it a day. But we got through our first part of algorithms. In the next section, I don't know if we'll be able to get through it or not. Maybe I'll do like an extra long course finale, but I feel like people don't want it to be longer, you know? After a while, your brain kind of gets tired. We'll see what happens. We'll try and get through the last 3 in algorithms part 2. If not, we don't. Whatever. If I'm being dumb and it takes me 20 minutes to do one, then we'll call it one. But anyways, thanks for tuning in today, guys. Like I always say, happy coding. Love y'all.